Section 4.7, Video 1, Odds, Expected Value, and Binomial Experiment. In this video, we will cover the following objectives: calculate odds, and convert between odds and probability. Let's start with a few definitions. The odds in favor of an event E are the ratio of the probability of event E happening compared to the probability of event E not happening. That could be written as probability of event E compared to probability of not event E. It could also be written and expressed using the number of times event E occurred compared to the number of times event E did not occur. Looking at the odds against event E would be the ratio of the probability of event E not happening compared to the probability of event E happening. It's basically the reciprocal of what we just wrote a second ago for in favor. Again, we could write the odds against event E using the number of times event E did not occur and the number of times event E did occur. Odds can be expressed in several ways. A few common ways are as follows, using the word to. For example, you could use 5 to 8. There are 5 animals to every 8 veterinarians. Okay. The fraction bar could also be used. There are 5 animals to every 8 veterinarians. A colon is another common way to express odds, 5 to 8. The word in is another one. 5 animals in 8 veterinarians, as examples. In the blue box, you're going to notice the same ratio we just discussed for odds in favor of event E and odds against event E, using both probability and also number of times an event occurred. Example 1. Last year, the LSU Tigers women's basketball team won 34 of their 36 regular season games. And we're going to find the probability that the LSU women's team wins a game, probability that they don't win a game, lose a game, the odds in favor of winning a game, and the odds against winning a game for that LSU team. Sometimes it's nice to be able to put all of the information in a small table. So let's look at the number of wins. And instead of saying the number of not wins, we could also call that as the number of losses. In this case, it says that there are 34 wins and there are a total of 36 times that they played. So in this case, we can work backwards, and if there's 34 wins and 36 times that they've played, there are 2 times that they had a loss. So let's look at part A, probability of a win. In this case, we're going to look at the number of wins, 34 out of the total, 36, and then always reduce. In this case, if we reduce them both by 2, we end up with 17 out of 18. Part B is the probability of not winning or losing a game. In this case, we're going to put in the numerator the number of losses, there were 2, out of the total, 36, and then reduce for 1 out of 18. Part C, now we're looking at the odds in favor of winning a game. One way to calculate this is our probability over probability. So the probability of a win compared to the probability of not winning that loss. Our probability of winning, we said, was 17/18, and the probability of a loss is 1/18. Using our arithmetic, we can change our division into a multiplication by the reciprocal, reduce, and get 17 to 1. So the odds in favor of winning for the LSU women's Tiger team is 17 to 1. Now in this case, whether it's written in fraction form or written in any other form for odds, we would not reduce 17 over 1 into just 17, because remember that when you're using odds, you're always writing it as comparison of two values. This would be the number of wins to the number of losses. So we wouldn't be able to go down to just one number. It always has to be a comparison of two. Part D is asking about the odds against the LSU women's team winning a game. So in that case, the probability of a loss is in the numerator, or the not wins, and the probability of a yes win is in the denominator. The probability of a loss, we said, was 1/18, and the probability of a win was 17/18. Using our arithmetic, we can take that division and convert it to multiplication and reduce to get 1/17. Notice that the odds in favor of a win and the odds against a win, if they're written in fraction form, are really reciprocals of each other. If they're written with a colon, they're just written in different orders. In this case, the win is written first and the number of losses is second. And in this case, the number of losses is first and the number of wins is second. Remember that we could also write this using the number of wins over or compared to the number of losses. Looking back at our chart, we said that there were 34 wins and 2 losses. So 34 wins to 2 losses would reduce to the same 17 over 1 that we got whenever we calculated it with probability and probability. The same thing would happen when we were looking at the odds against a win. If we looked at the number of losses, the number of against wins first, and the number of wins, we would have 2 losses to 34 wins, or it would reduce to 1/17 as a fraction. And it would be written as 1 compared to 17 with our colon. Let's try another example. Example 2. In any given year, approximately 24% of Chicago Marathon participants run the race in less than 4 hours. And then we're going to find, very similar to last time, probability of finishing less than 4 hours, probability of not finishing less than 4 hours, and then the odds in favor of finishing less than 4 hours and the odds against finishing in less than 4 hours. Let's take that 24% and let's write that as a fraction. One way to write it as a fraction would be 24 out of 100. And then we could write that and fill in our chart. There are 24 times that a person finished in less than 4 hours. And there are 100 participants total. When you write a percentage, or if you write a fraction, 24 out of 100, we're looking at the number less than 4 hours, and we're looking at the number total. And so in here, we could take 100 and take away the 24 that we know finished less than 4 hours, and would end up with 76 that did not finish in less than 4 hours. And now we can calculate our probabilities and our odds. The probability of finishing in less than 4 hours would be the number that finish in less than 4 hours compared to the number total. So that would be our 24 out of 100, and then reducing, we could get 12 out of 50, reducing again, 6 out of 25, and that would be our final probability. Final reduced answer. Part B, to find the probability of not finishing in less than 4 hours, we would look at the number that do not finish in less than 4 hours compared to the number total. Looking at our chart, there are 76 participants that did not finish in less than 4 hours and 100 total. And reducing, we would reduce down to 19 out of 25. Part C, the odds in favor of finishing less than 4 hours. In this case, we could use the calculation of the ratio of probability over probability, or we could use the number. So we would start with, in favor of finishing less than 4 hours, the number that did finish in less than 4 hours, which would be 24. And then the other comparison would be compared to those that didn't finish in less than 4 hours would be 76. Reducing that, we would get 6 to 19. Or writing it in a different way, 6 to 19. The odds against finishing less than 4 hours would start with the first comparison, those that did not finish in less than 4 hours, 76, compared to the number that did, 24, and reducing, we would get 19 compared to 6, or if you wanted to write it using a colon, 19 compared to 6. Let's take a look at example 3. The odds of finding a 4-leaf clover are 1 in 5,076. We're going to find the odds and the probability. Notice that in this question, different than in examples 1 and 2, we were given the odds, where in examples 1 and 2, we were given a probability. If we were given the odds of finding a 4-leaf clover, the 1 represents yes finding the 4-leaf clover, and the 5,076 represents not finding the 4-leaf clover. So we can make our chart the number that do find a 4-leaf clover compared to the number that do not find a 4-leaf clover. And then we usually end our chart with our total. So in this case, the 1 represents the number that do find the 4-leaf clover, and the 5,076 represents those that do not, because when we're given the odds, we are comparing the two different extremes, those that do and those that do not. And our total would be to add them together, and that would be 5,077 people total. So part A, find the odds in favor of finding a 4-leaf clover. And that's actually what was given to us. So that is the 1 to 5,076. The odds against finding the 4-leaf clover would first mention those that don't find the 4-leaf clover, 5,076, compared to the 1 that does. Part C, the probability of finding the 4-leaf clover. Probability is always the number of times finding the 4-leaf clover, which was 1, and then the denominator, it's the total, which is 5,077. And then finally, part D, probability of not finding a 4-leaf clover would be to start out first with the number that do not find the 4-leaf clover, 5,076, to those that, to the total, 5,077. And that ends example 3.